So, an update on my little 2D game engine here that I'm making in the Windows GDI. So, I rewrote a couple of things, and I didn't like the way I had one class running that kind of had game-specific code, so I kind of shied away from that. I went with a modular system, and really that's when my light bulb went off. So I figured I'd make a video about this and explain it because it might help other people who are embarking in this endeavor of making their own 2D game engine. Just for fun. This stuff is a lot of fun. It's very challenging. So let me just give you an example of what I've done here. I've created these two sprites here. Well, let's just focus on one. But what these things are, they are little platforms that propel you upwards. Now, if I jump here, you can see I can only go so high. I can't really get up there. But if I jump on this little thing right here, I can get up there. It propels me up. And I'm going to be showing you how that is working. Now, my blue guy here is controlled by a class called the player class. And this particular object here is called a pop block. That's what I decided to call it. And that block, or that sprite, is being controlled by another class. Now, the actual the sprite itself is another class as well, as you will see. And in order for all this to happen, we have about 3 sprites talking to each other. Because that's the cool thing about objects, is that they can talk with each other. So what you do is you think about making a 2D game engine and the objects that are in that 2D game engine as modular in a way that, think about it like a big box with like different connections on the sides, and one connection takes information and one side gets information, or you can get information and you can put information. So you can do things, put information inside it, get information out. So that's kind of the approach that I decided to take with it, and that really helped. Before I implemented this, I was specifically accessing the actual player sprite, and I didn't like that. So instead, I came up with a different system. So I added, taking that analogy that I just talked about, data in, data out. I implemented what's called a radio system. I thought that would be fun. Like, okay, let's have the sprites talk to each other, like a little radio. You send the message, and then another object intercepts that message and does something with it. So let me show you what happens here. Is this sprite jumps on top of this object, and after a certain little timer goes off, it sends a message. The object that controls that sprite sends a message to that sprite, this sprite right here, and says, okay, catapult whatever was on top of us. So the object that is, how do we say this? Okay, the object that is controlling this sprite, the class that's controlling this sprite, this is going to be confusing to explain. The class that is controlling my player sprite will receive that message from the catapult, because it's going to detect that it was on top of it, and it's going to send a message to that sprite. And then the object that I'm using to control that sprite checks the radio messages and says, oh look, we have a message here, let's see what it is. And it sees that, okay, we've been asked to catapult. That's what I decided to call it. So immediately the sprite activates the catapult, which is in other words just a really big jump. Now you can make it really crazy. So anyway, let's show some code, and let's see how this let's see what it looks in code. So let me just show the sprite class here. These are the radio messages I was talking about. I kept it fun, so I kind of, let's just give it a radio theme. So you can see I have a I have a function here. These are functions that are inside the all-purpose sprite class. One is called radio transmit. The other one is called check radio. One is called got radio message. The other one is get radio frequency. I use that one to kind of retrieve float values, because maybe there might be some integers with that. I mean, I can expand on that later and maybe add more data types, and maybe two more than that. Maybe a struct, with different kinds of data that we can read from a certain event message. And then there's a get radio message, which retrieves basically a string that has what the message is. So let's see this in action. Let's see. Maybe if we scroll down here, I might have. Here we go. Here's radio transmit. This is what it looks like. All it does is it stores the value in string, and of course the frequency, and it sets a flag to true, meaning, hey, we've got a message. So that will evidently set check radio. When we call check radio, it will return whether this is true or false, and we can check a message if there is one. Now, got radio message is what we would call once we read that message, and this would set it back to false, so that we're not calling it again and get erroneous messages. Get radio frequency, again, just returns whatever this float variable was, or this value. And get radio message just returns the string. So pretty simple stuff. And here we have this is the class. This is the class that controls these objects here, the pop blocks. That's what I decided to call them. And you'll see here, somewhere around here, I want you to pay attention. I set a timer using time get time. I set a timer. Once that certain timer goes off, we send a message. Get last hit returns the last item that was on top of us. And we send a message to that sprite, and we use radio transmit. We say catapult, and we send in the whatever frequency we set for the radio. In this case, this would be the factor of the jump, like how force or how fast should it go up. And then that gets stored in the actual sprite. Then my player class, which is this one right here, this is what moves the blue guy on screen. This class, it checks for the messages, and every time it updates, it checks for these messages. So right here we say P sprite. It's accessing the sprite that it's controlling. It says, okay, let's check the radio to see if we got a message. And if we do, then this code here executes. So the message catapult is intercepted here, catapult, and then here's the code that gets that catapult going. We set the jump factor to whatever the frequency was, and we say, okay, got the radio message. This sets it to false so that we don't intercept it anymore. And we say jumping is true. So this will start a jump. Evidently, if we scroll down here, we'll see the jump algorithm, and it takes off from there. So I don't know, maybe that looked confusing, but yeah, that's how it worked. So I can keep adding way more different types of different scenarios here, and I don't have to worry about I don't have to worry about messing around with this class here, because this is the one really that I don't want to touch, because I want to make it reusable. So again, let's launch that now that we seen that. And once again, here's that player class controlling that sprite. We jump on top. That sprite detects that we're on top of it. It sends a message to that sprite, hey catapult, and our player class intercepts it and processes that command. So that's three sprites talking to each other through classes, and I think that's really cool. And yeah, you can do amazing things like this. Yeah, so I just wanted to show that, and that's all I got for you guys for this update. If I got something else, I'll let you know. By the way, this is the start of the animation feature that I will be implementing. These sprites here, they're actually flipping between black and yellow, giving us this blinking thing here. All I'm really doing is I'm just flipping between two bitmaps to kind of do that. But eventually, the idea is to have like a sprite sheet with different settings, and you'll be able to create different types of animations. I don't know if you ever played Sonic the Hedgehog. It tends to have all these flashing stuff. I mean, that's crazy. I'm not going to do anything like that. But yeah, Sonic the Hedgehog really goes crazy with that kind of stuff, and you get all these flashing lights, and it makes the level look alive. But sometimes I think it's really overkill, especially in Chemical Plant. You've got so much flashing lights and so many little things activating. But I guess with the music that they're using, like, it kind of matches up with the game. It makes it seem energetic. So I guess it works. Anyway, that's all I got for you guys. Thank you so much for watching, and that's it. If you did saw any stuttering, I do use OBS Studio to record these examples, so that's probably why it stuttered. The game itself doesn't stutter. And again, if you're embarking on this journey like I am, I post updates whenever I can. If I've got something interesting to show, I show it. But other than that, that's all I got. Bye bye.